Okay, so number 12 says, okay, so number 12 says, Robert is finding the output values for the equation a plus 7 times 3 equals b. He wrote a few statements about the input and output values. So he solved it, and he said that when a equaled 3, b equaled 30. When a equaled 4, b equaled 33. When a equaled 5, b equaled 36. But when you guys worked these equations out, you figured out that when a equals 3, b equals 24. When a equals 4, b equals 25. And when a equals 5, b equals 26. Because you knew, well, 7 times 3, the order of operations tells us to do parentheses first. There are no parentheses, so we move on to step 2, which tells us to multiply and divide from left to right. So you did 7 times 3 first, which is 21. And then you added a. So 21 plus 3 is 24. 21 plus 4 is 25. 21 plus 5 is 26. Those are different than Robert's. So what you had to do next was figure out, okay, what did he do wrong? So in order to do that, what you want to do is you want to look at the problem and you want to think, well, what might someone do wrong? What do you think someone might do wrong when they're looking at a problem with multiple operations? Zari.
He may have added before he was multiplying.
So he may have not followed the order of operations. He may have just solved from left to right. Well, let's test that out. If a equals 3, that means if he did it incorrectly, he did 3 plus 7 first. Class, 3 plus 7 is 10. Then he might have multiplied. 10 times 3 is
30.
Is that what he got?
Yes.
Let's
30.
check to make sure. Now, if he did the order of operations incorrectly and added first, he would have done 4 plus 7, which is 11, multiplied by 3, which is
33.
Is that what happened?
Yes.
Yep, let's test one more time. If he did the addition first, he would have added 5 plus 7, which is
12.
then multiplied by 3, which is
36.
36. So, what was Robert's mistake? Aaron.
He did the addition or subtraction first before the multiplication.
So, he did, if you don't have this, you can go ahead and do it, but I think I made sure everybody had it. He did the order of operations incorrectly. He added before he multiplied. So when you're doing these types of problems and you have to correct someone's work, you need to think, okay, if I wasn't really listening when we did this lesson, what might I do wrong? Well, a really easy thing to do wrong when you have multiple operations is to just do it from left to right instead of following the order of operations. Now, we have to rewrite this equation so that Robert's values, his answers, are correct. So that means we take this exact same equation. A plus 7 times 3 equals B. But we just change it a little bit so that his answers are right. How could we change this to show that you have to do the addition first? Carla.
We would put parentheses around it.
Around what? The whole thing?
No.
What do we put parentheses around?
We will put it around.
Remember, parentheses are what happens first. We want Robert's answers to be right. In order for Robert's answers to be right, which part of this equation do we have to do first?
We have to put parentheses around 7 times 3.
Is that right? Zadie?
No.
No. Why?
Because in order to make his answer right, we have to put it around a plus 7.
If we put parentheses around 7 times 3, which part would we do first, Carla?
The parentheses.
The parentheses, which would be what equation?
7 times 3.
7 times 3, which would be
Which would be
21. And then if we change this to 3, well, we still get 24. So is he correct if we put parentheses around 7 times 3? Is his answer correct when we have parentheses around 7 times 3, Carla?
No.
No. So, the parentheses can't go around 7 times 3. Also, do we even need to put parentheses around 7 times 3 to show that we have to do it first? Do we even need parentheses there, Michaela?
No.
No. Why do we not need parentheses to show that we have to do the multiplication before the addition?
Because multiplication and division comes before adding and subtract.
Because multiplication and division already comes before addition and subtraction in the order of operations. So, Zadie, where do the parentheses need to go to show for his answers to be correct?
Around a and 7.
Around a plus 7. Then yes, we would do the addition first because we have to do the parentheses first. So if we replaced a with 3 and added 7, we would get 10. Bring down the rest. 10 times 3 does equal 30. So that's what you had to do for number 12 on yesterday's independent practice. Does everybody understand? Some of you did that already. Some of you did this part, but then got a little confused here. When it says to rewrite the equation, that's your equation. So you rewrite it, but you change it a little so that he's correct. So make sure if you do not have this, that you have it now while I go and get the computer ready for today's lesson. So now, remember when I said yesterday that today's lesson is exactly the same as yesterday's lesson? The only difference is we're adding input-output tables. So instead of look at number 11 on yesterday's independent practice where it says, set up an equation machine to show x plus 4 divided by 3 equals y. Find the values of y when x equals 8, x equals 11, and x equals 12. And then it says when x equals 8, y equals 4. When x equals 11, y equals 5. When x equals 20, y equals 8. Instead of having all of those words and just those little lines, you're just going to have an input-output table, like the try it that we did yesterday. So, let's review the order of operations. Class, step 1.
Parentheses.
Step 2.
Multiply and divide left to right.
Multiply and divide from left to right. Step 3.
Add and subtract from
Add and subtract from left to right.
Add and subtract from left to right. Okay. Read the sentence under the title. Oops. Zadie. Sentences.
You have used tables to show equations with one operation. A table can also help you show equations with 2 operations.
There you go. Same thing. We've done input-output tables with 1 operation. We've done equations with 2 operations. Now we're just combining them. Input-output tables and equations with 2 operations. Okay, finger or pencil on example 1. Read in your head while I read out loud. We're going to go through every period. We're going to visualize. We're going to imagine this happening. Sam earns $7 each time he rakes his neighbor's lawn. Okay? Imagining him raking a lawn and his neighbor giving him $7. And then I'm imagining him going to his other neighbor, raking the lawn, and that neighbor giving him $7. Okay? So that means each lawn he rakes is $7. Let me draw a picture of that. Here's the lawn. Each lawn is $7. But instead of buying it like the books, when he rakes it, he gets $7. Okay, let's go to the next sentence. He also earns $5 each week for doing chores at home. Okay? I'm imagining a broom, or whatever, that looks more like a rake, but it's a broom. We'll make it a mop. And each time he does these chores, he gets $5. Okay. Does he get $5 for each chore? Cullen?
No.
No, he gets $5 each time he does all his chores. For how long?
1 day. Oh. 1 week.
1 week. Okay? So each time he mows one lawn, he gets $7. Each time he does all his chores for a whole week, he gets $5. Okay. Sam wants to find out what he will learn in a week if he does chores and rakes the lawn 1, 2, and 3 times. So that means, are we worried about more than 1 week right now? Look at the question. Are we worried about more than 1 week? Lena,
Yes.
is that right? Are we worried about more than 1 week? Carla?
No.
No. How do we know? How do we know that we're not worried about more than 1 week?
Because he wants to know how many times, how much money will he get when he rakes the lawn 3 times.
Okay, that does not answer that question. Aaron, how do we know that we are only worried about 1 week?
Because it says Sam wants to find you in a week.
Because it says a week. So Lena, do you see that? Do we see anywhere else where it has a number and weeks?
No.
No. So just 1 week. So how many times will he be doing his chores in this problem? Zadie? Once. Because we're only worried about 1 week. So we're only worried about 1 week of chores. So what operation do you think we're going to be doing with the $5? Adding, subtracting, multiplying, or dividing? If we're only worried about 1 week of chores. Victoria?
Adding.
Probably adding. Because are we going to repeat this $5 at all? How many times is he doing chores in this problem? Class? Once. So are we going to repeat this $5 for chores?
No.
No. But if we go to the rest of the problem, it says he rakes the lawn 1, 2, and 3 times. So what are we repeating? Are we repeating weeks, chores, or raking? Sorry.
Raking.
Raking. So let's write the equation. Don't look at this. Listen as I explain. We know he makes $7 each time he rakes a lawn. We know that's going to be changing. So what should we use to show that we're going to be changing the number every time we solve? Michaela?
An addition sign.
What should we use to show that we're going to be changing a number each time we solve? Cullen?
A variable.
A variable. Since you told me that. Well, actually, let's use the variable they use. T. So we know T is representing the number of times he rakes. If he gets $7 every time he rakes, what operation are we going to be using to figure out how much money that is? If he gets $7 every time he does this, So we're figuring out, okay, 1 time, 2 times, and 3 times. Do we add the number of times he rakes to the money he gets for it? Do we subtract the number of times he rakes from the money he gets from it? Do we multiply the number of times he rakes by the money he gets for it? Or do we divide the money he gets from the number of times he rakes? Smith.
We multiply.
We multiply. Because each time he rakes, we repeat that $7, right? He rakes once, he just gets $7. He rakes twice, well, he gets $7 each time. So $7, $7. If he rakes 3 times, we repeat it 3 times. $7 here, $7 here, $7 here. Very good. So now this will tell us how much he makes for raking the lawns. Is that all that he's earning though? So we already kind of figured this out. What do we do with the money for chores? We're only talking about 1 week. What do we do with the money for chores? Zadie? We add the money for chores. Zadie, can you tell me why we're not multiplying, dividing, subtracting, or whatever?
Because it's just for 1 week.
It's just for 1 week. So how many times did he do chores in this problem?
Once.
Once. Do we multiply when we know they only did it 1 time?
No.
No, we just keep the number because 5 times 1 is 5. So we don't need to multiply again. So now we have our equation. We have the $7 multiplied by the times he rakes plus the money he gets for chores. $7 from raking times T, the times he rakes the lawn, plus the dollars he earned from the chores equals his total amount of money. They also put parentheses around 7 times T. The reason for that is they want to show you this together is going to equal the amount of money he gets for raking. Once we figure out the amount of money he gets for raking, then we can add the $5 from his chores. So, to fill in this table, we just solve each time. So, everybody, get out a separate sheet of paper because we don't have enough space. Should have had you do that already. Go ahead and get out 2 because you're going to need 1 for the independent, excuse me, for the examples and guided practice, and then a separate one for independent practice. Actually, you can use the same one, but go ahead and get out 2 just in case because you're going to need a lot of space. Okay, just make sure you label. So on your separate sheet of paper, go ahead and label example 1. And then we're going to rewrite our equation, but instead of writing times T, we're going to use our first input number. So our new equation, instead of looking like 7 times T plus 5 equals M, is going to look like 7 times 1 for the 1 time he raked the lawn, plus 5 equals M. Okay, so we know we do parentheses first. Class, 7 times 1. 7. We have our caret. We bring down the rest of the equation. We don't have any more multiplication and division or parentheses, so we skip to step 3, where we add and subtract. 7 plus 5 is 12. Bring down the rest of the equation. So, if Sam rakes the lawn 1 time and then does his chores, how much money will he get? Class?
$12.
$12. Please add that dollar sign. and then go back to your separate sheet of paper, because we're just going to do the same thing, but instead of replacing t with 1, we're replacing t with 2 for the 2 times he rakes lawns. So I'm going back to my separate sheet of paper, going to the next line, and rewriting the problem, except I'm writing 7 times 2 plus 5 equals m this time. Step 1, parentheses. Class, 7 times 2 is
14.
14. Bring down plus 5 equals m. I have no more parentheses. I have no multiplication and division. So now I'm going to add and subtract. Take a minute to solve. 14 plus 5 is
19.
Bring down the rest of the equation. So, if Sam mows the lawn twice, how much money will he make, class?
$19.
$19. Okay, let's do it again. Do you see how this is just like yesterday?
Yes.
But instead of saying if t equals 1, then m equals $12, we just have a table. Saves ink, saves space. So let's go back to our piece of paper, rewrite our problem, but instead of leaving the t or replacing it with 1 or 2, this time we're going to replace it with the 3 for the 3 times he mows the lawn. 7 times 3 plus 5 equals m. First we do parentheses. Class, 7 times 3 is
21.
21. Bring down the rest of the equation. We have 21 plus 5 equals m. No more parentheses. No multiplication and division. Yes, adding and subtracting. Take a minute. Class, 21 plus 5 is
26.
26. Bring down the rest of the equation. So, if Sam rakes the lawn 3 times, how much money will he get?
$26.
$26. Zari, please read the words under number 2 and fill in the blanks. Read it slowly. So pause at the period so we can write. Pause after you say what goes in each blank so we can write.
Okay. So during 1 week, if Sam rakes the lawn once, he will earn $12.
Okay?
If he rakes the lawn twice, he will earn $19.
Okay?
If he rakes the lawn 3 times, he will earn $26.
Very good. Everybody with us? The part that's going to take the most thinking in this lesson is when you get to the independent practice and you have to write your own equations. But I'll walk you through that on example 1 and 2. And we might do, if we have time, we'll do number 10 on the independent practice together. Your homework, you will have to write 2 equations. There are 2 word problems. You will have to write the equations. Just think, what is being repeated? What's happening more than once? If it's happening more than once, you're multiplying it. If it's only happening once, if it's happening more than once, or you're breaking it up more than once, you're going to multiply and divide. If it's only happening 1 time, you're adding and subtracting. And then, like the lesson we did on Monday maybe, I think it was, you might, if you have to do the adding and subtracting, like when the boy had the cars and he lost 2, and then he divided them amongst himself and his cousins. Remember, we had to subtract first in order to figure out how many he had after he lost. So if you have to subtract or add before you multiply or divide, what do you have to put around the subtraction or addition part to show you have to do it first? Class?
Parentheses.
Parentheses. Okay, let's move on to example 2. Helper number 1, please helper number 2, please sanitize, erase, sanitize. Okay. Everybody, finger or pencil on example 2. Oh wait, read the sentence at the top, Victoria.
Equations can have multiple operations.
We know that. That's old news. We've been doing that for like 3 days now. Actually, we've been doing it all year. So, finger or pencil on example 2. Read in your head while I read out loud. Complete the table to find output numbers when x equals 2, 3, 4, and 5. Do we have a real world problem here? Do we have to worry about writing an equation? No, we already have it. 2 times 9 minus x plus 3 equals y. Ooh, this time we have 3 operations. Sometimes problems could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 25 operations. We've already done this though. But let's look again. How do we do it when there's more than one? Well, they already solved what would happen if x equals 1. Here, we're going to solve what happens if x equals 2. So, we're rewriting our exact equation. 2, use your pencil, go over top, times 9 minus 2, we're replacing that x with 2, plus 3 equals y. And now we're just going to use the order of operations. Step 1 tells us to do parentheses. We have parentheses, so that means we need to solve 9 minus 7 first. Sorry, 9 minus 2 first. Class, what is 9 minus 2?
7.
7. Then we're going to bring down the rest of the equation. 2 times 7 plus 3 equals y. This is where you're going to have to be careful because some of you if you're not careful, you're going to make silly mistakes. Because you're going to just start to move on, even like say there was division here, and then you might do this first. I'm sorry, if say there was division here and adding here, some of you might add here and then divide. Sometimes it won't work that way, so you have to make sure you follow the directions. But in this case, we have no more parentheses, so we move on to step 2. We do have some multiplication. So next we're going to do 2 times 7. Class, 2 times 7 is?
14.
14. Then we're going to bring down the rest of the equation. 14 plus 3 equals y. We have no more multiplication and division. Just because I multiply once, does that mean I should go ahead and move on to the next step? No. Check to make sure there's no more multiplication or division. Does everybody understand? There is no more multiplication or division, so I'm going to move on to step 3. Add and subtract from left to right. We'll only have one addition problem left. Take a second. Class, 14 plus 3 is?
17.
17. Bring down the rest of the equation. Do I have anything else to solve? Class? No. So when x equals 3, y equals?
17.
17. I'm going to go ahead and fill in my, when when x equals 2, y equals?
17.
17. Okay, now we're out of space, so go to your separate sheet of paper. We're going to rewrite our equation, but instead of x or 2, this time we're going to write 3. Thank you, Lena. Okay. So, on your separate sheet of paper, you should have example 2 labeled. And then let's rewrite the equation, but this time we're going to replace the x with 3. 2 times 9 minus 3 plus 3 equals y. Make sure when you're copying over on your separate sheet of paper that you're copying everything correctly. Don't make a silly mistake and copy something incorrectly and then get all the answers wrong after, okay? So now, we just follow the order of operations. Parentheses first. Class, 9 minus 3 is?
6.
Class, 9 minus 3 is?
6.
6. Bring down the rest of the equation. Two times 6 plus 3. We have no more parentheses. So let's move on to step 2. Multiply and divide from left to right. We do have some multiplication. Class, 2 times 6 is?
12.
Confidence, guys. Some of you are dropping off. Bring down the rest of the equation, and we have 12 plus 3 equals y. We have no more multiplication and division, so let's move to step 3. Add and subtract from left to right. We have addition. Take a second. Class, 12 plus 3 is?
15.
15. Bring down equals y. We have nothing else to solve. So when x equals 3, y equals?
15.
15. And let's also put it in our table. We are not going to do the guided practice together because I don't think you need to. We're going to do number 10 on the independent practice instead. Because number 1 is this. And you already know how to do it. Okay. Go to your separate sheet of paper and rewrite the equation again, but this time instead of writing x or 1, 2, or 3, you're going to replace it with a 4. So we have 2 times 9 minus 4 plus 3 equals y. Step 1, parentheses. Class, take a second. 9 minus 4 is? 5. Bring down the rest of the equation. 2 times 5 plus 3. No more parentheses.
10.
So let's multiply and divide. Class, 2 times 5 is?
10.
10. Bring down the rest of the equation. 10 plus 3 equals y. We have no more multiplication and division, so let's move on to step 3. Take a second. Class, 10 plus 3 is?
13.
13.
13. Bring down the rest of the equation. Class, when x equals 4, y equals?
13.
13.
13.
Okay, last one for this one. So does everybody see? We're just doing the same thing like 3 times in a row and just replacing one. We're changing one number. Oops, wait, let's fill in our table. And go to your separate sheet of paper, rewrite the equation, but this time we are replacing the x with 5. 2 times 9 minus 5 plus 3 equals y. Again, make sure that you are including every number, every operation symbol, every parentheses. Because if you forget the parentheses, but you still do 9 minus 5 first, you're not correct. Because if you forget to write the parentheses, we would have to do 2 times 9 first. Okay, we have 2 times 9 minus 5 plus 3 equals y. Step 1, parentheses. Class, take a second. 9 minus 5 is? 4. Bring down the rest of the equation. And we have 2 times 4 plus 3 equals y. We have no more parentheses, so let's move on to multiply and divide from left to right. We do have some multiplication. Class, 2 times 4 is? 8. Bring down the rest of the equation. We have 8 plus 3 equals y. Take a second. We have no more multiplication and division, so we're moving on to adding and subtracting from left to right. Class, 8 plus 3 is?
10.
Class, 8 plus 3 is?
11.
11. When I say take a second, that means solve it correctly. We have nothing else to solve. So class, when x equals 5, y equals? 11. Now I notice that usually we've seen when the input numbers go up, the output numbers also go up. They also increase. That's different this time. Who thinks they know why? Why are the output numbers going down, decreasing, but the input numbers are increasing? Victoria?
Because the equation, the 9 minus 1, 2, 3, 4, or 5,
Mm-hmm.
the parentheses are around it, and it's a subtraction equation, and you have to use a subtraction equation all the time, and it's first.
Okay, so I understand what you're trying to say. Victoria is saying that since we're subtracting the input and we're subtracting a higher and higher number every time, that means this subtraction problem is ending up with a smaller number each time. Because we're subtracting numbers getting larger and larger, our answer is getting less and less. We're subtracting more and more each time, so that means our answer is getting less and less. Okay. Yes, Zadie.
I knew it, but I couldn't put it into words.
Yes, that's fine. Just try it like Victoria, and I can interpret what she's trying to say. Okay, so we are not going to do the guided practice together because I don't think we need, you know what to do. After I do number 10 with you, you can go ahead and begin. I'll do the guided practice for those that might still need a little extra, okay? Okay. Everybody should have had the chance to read number 10 at least once to themselves. And now let's read it out loud. It costs $3 to park at the fair. Tickets cost $6 each. Oops, I'm sorry. It costs $3 to park at the fair. So I'm imagining this little car is $3. Okay? It's parking. Tickets cost $6 each. Okay? So now I'm imagining a ticket, and it's $6. Okay? One car, $3 to park. One ticket is $6 to buy. How much will it cost for a family of 4 to go to the fair? Complete the table to solve. Okay. How much will it cost for a family of 4 to go to the fair? Let's think of this family of 4. How many cars will a family of 4 park? Like a mom, a dad, a brother, and a sister. How many cars will they park? Zadie?
1.
1. So, what do you think I'm going to do with that $3 for parking the car? Add, subtract, multiply, divide. How many times are they parking a car?
1.
1. Are we subtracting money? Are we adding it? Are we multiplying it? Are we dividing it? Who can help her out? We're parking the car once. What are we going to do with that cost for parking the car if we're only doing it once? Are we going to repeat it? Are we going to break it up? Michaela?
You're only going to pay once.
So what does that mean? What operation?
Multiplication.
Multiplication means I repeat it. Am I repeating this $3 at all?
No.
Think about the total cost. Is this $3 going to repeat? Are we breaking it down between parking spots? Are we taking it away from the total cost? Are we getting it back? Or are we adding it to the total cost? Think about example 1. What did we do once in example 1? Aaron, what did we do once in example 1? We did chores one time. What did we do with the amount of money for chores? We added it. Here, we're parking the car one time. So what are we doing with the amount of money for parking the car one time, Aaron? We're adding it. If we only do it once, it's either adding to the total or subtracting from the total, depending on the situation. In this case, we're trying to find the total amount of money they're going to pay. So we have to add the $3 for parking to their total cost. Now, there's a family of 4, and the tickets cost $6. How many tickets will a family of 4 need to get into the fair? Lena? 4. So, how many times do we need to add the $6? 4. Do we need to write plus $6, plus $6, plus $6, plus $6?
Yeah.
What can we write instead to show that they need 4 of these $6 tickets?
Plus 6.
Plus 6? Can we add tickets in dollars?
No.
So what do we need to do to show that we need 4 of these tickets?
We could do parentheses 4 times 6.
4 times $6. Because remember, we don't have to write $6 plus $6 plus $6 plus $6. We're repeating this $6 4 times, 1 for each family member. When we repeat a number, remember, multiplication is another repeated addition is another way to do multiplication. So instead of writing plus $6 plus $6 plus $6 plus $6, we can write plus 4 times $6. $6, 4 people, each need to pay $6. Carla, sit up. Please do not write plus $6 plus $6 plus $6 plus $6. It's like in the other lessons where we bought 4 books for $5. So we did 4 times $5. 4 books for $5 each is 4 times 5. That will give us the total cost. But look, we have our input-output table that already gave us our equation. But why would I not just say, don't worry about writing the equation, just use this one? Does that give you practice for when you do have to write your own later? No. Victoria, yes. Is it quick?
Yes.
What is it? Okay.
So do you want us to write C or Y?
Oh, you can put Y. I forgot. Yeah, because it is the same. So let's put Y. So here, are we imagining, do these input numbers equal the amount of cars parked or the amount of tickets purchased? Look at it. Is the input the number of, so that's X, is it the number of cars parked or the number of tickets purchased? Cullen,
Tickets per,
how do you know that it's the number of tickets purchased?
because X is the input and there's 4 people, so there's gonna be 4 tickets.
Good. Another way is, if this was the number of cars parked, that means each car costs $6. In the problem, does each car cost $6? No. What costs $6 in the problem? Lena,
Each ticket.
each ticket. So if you're repeating, multiplying, remember multiplying and repeating, that's what we're doing. They are synonyms. If you multiply something, that means you're repeating it. Anything. Like if I multiply, if my cats multiply, that means more cats are happening. Okay? That means they're having babies. They're repeating. So, I don't have cats. So, if you have this $6 times an input, that means whatever costs $6, that's what the input is. So, we are doing this table. We know if one person comes to the fair, it costs $9 for them. $6 for the ticket, because 6 times 1 is 6, plus $3 for parking equals $9. So now we need to solve how much it would cost for 2, 3, and 4 people to go to the fair total. But we're imagining they're all in the same car. These 2 people are in the same car. These 3 people are in the same car. These 4 people are in the same car. And then on our line, we're going to solve how much it costs for a family of 4. So now go to your separate sheet of paper, label number 10, and we're going to start by solving how much it'll cost for 2 people to go to the fair. So we're going to rewrite our equation, but instead of writing x, we're going to replace it with the 2 people. So $6 times 2 people times 2 tickets plus $3 for parking equals y. Mason, what do we need to do first?
Solve the problem in the parentheses.
Solve the problem in parentheses. So, $6 times 2 is
$12.
$12. Then we're going to bring down the rest of the equation. You know you're on the right track when if you're adding or subtracting, you have the same unit. If you have a different unit, that means you're on the wrong track. Because can I subtract ticket, or can I add tickets to money? Can I add cars to money? No, I can only add money to money. Okay, thank you, Mason. What do we do next? Cullen?
We add
We add. $12 plus $3 equals
$15.
$15. We bring down. Do we have anything else, class?
No.
No. So if 2 people go to the fair, how much will it cost them?
$15.
$15. Now let's figure out how much it's going to cost for 3 people to go to the fair. Oops. We're going to rewrite our equation. But what is it going to look like? Lena?
6 times
Oh, 6 what?
$6 times 3 parentheses 8 plus 3 plus.
Are you changing anything else? Don't worry about that. We know x equals 3, so we replace with the x with 3. Do we change anything else? No. So we have $6 times 3 plus
$3.
what else?
Equals 1.
Equals y. Oops, that's me. Aaron, what do we do first? We do the problem in parentheses, which is?
6 times
Loudly, please.
3. 6 times
6 what?
3.
$6 times 3, which is?
18.
$18. Come on, guys. Units, units, units. I will be taking off points for no units today. I will, on this homework. I will be taking off points for no units. A whole point. Do not fail an assignment because you did not put units. It is important to your understanding of what the problem is asking. Okay, then we bring down the rest. What do we solve next? Smith.
We solve $18 plus $3.
$18 plus $3, which is
$21.
$21. Class, do we have anything else to solve? No. So if 3 people go to the fair, how much will it cost them? $21. Okay, last one, and this will answer the question in our problem. How much will it cost for 4 people, for a family of 4 to go to the fair? Ethan, first we need to rewrite our equation. What is our equation going to look like? We know 4 people are going to the fair. So what is our equation going to look like? We're replacing that x with the 4 people. 6 what?
$6 times
$6 times 4 plus $3 equals y. Carla, what do we need to do first?
First, we need to check for parentheses.
We need to do the parentheses first. So do we have parentheses?
Yes.
So what do we solve first?
6 times 4.
6 times 4? 6 what times 4?
6 interviews.
Look at the problem. 6 what times 4? Look at the equation. 6 what? $6 times 4, which is what?
24.
24 what?
Dollars.
$24. Bring down the rest of the equation. What do we solve next? Michaela.
24 plus 3. Oh, $24 plus $3.
$24 plus $3, which is $27. Class, do we have anything to solve? Anything else to solve?
No.
No. So if a family of 4 goes to the fair, how much will it cost them?
$27.
$27. So everybody look. In these parentheses, we are solving how much it costs for the family to buy tickets. The parentheses tells how much the tickets cost. $6 for each ticket. How many family members? 1, 2, 3, 4. Then, once we find out how much the tickets cost, we added the $3 for parking. That's why that equation looks that way. That's why we have to do that's why it has the parentheses. Because we need to figure out how much the tickets cost before we can add the parking cost. Can you add the parking cost to the number of people that are buying tickets? No. That's why we're doing that. So, as you're writing equations yourself on word problems, make sure that you are figuring out, okay, what part do I need to do first? Like in the problem in example 1, you had to find out how much does he make for raking lawns before you can add the amount he makes for doing chores. Or the toy car problem. You had to figure out how many cars he had after he lost 2 before you could divide them amongst himself and his cousins. So make sure that's where the parentheses go. The part you have to do first before you can move on, that's where parentheses go. Any questions about this lesson? I'm going to give you the time now to do the independent practice. So I'm going to give you 20 minutes. I'll give you 25 to do the independent practice now. Yes, Michaela.
Use the same paper.
Yes, use the same sheet of paper. Number 1 through 9 on the independent practice. You're just doing exactly like what we did in example 2. You just have an input-output table and you're solving. Number 10, we already did. Number 11, you're doing what we did on number 10. You just only have to solve once. Make sure that you write an equation on the line. So you have to come up, what does my equation need to look like in order to solve this? Where do my parentheses need to go? What operation am I doing with these numbers? Number 12 is critical thinking with numbers. You're finding the error, which means what do you have to do before you can find the error? You have to find the, what? An error is a mistake. Before you can find the mistake, what do you have to do? Zadie?
You have to solve.
You have to find the right answer. Then number 13 is critical thinking with words. Look at your homework. You will have printed homework, but it's going to look the same. It's just going to be slightly different problems. Numbers 1 through 7 are just like the beginning of the guide of the independent practice. Numbers 8 and 9 are like numbers 10 and 11 minus input-output tables. You have to figure out what does my equation need to look like. Make sure that you write the equation with the answer. Number 10, you are solving. Obviously, all of the homework and all of the independent practice must be shown on a separate sheet of paper. Because even number 1, some of you have big hand and it's just not going to fit. So all of the homework and independent practice must be shown on a separate sheet of paper, other than obviously number 13 on independent practice because it's critical thinking with words. Okay, go ahead and begin. If you have any questions, I will come around and answer them.